Hi Arun, how are you?
I'm good.
Can you tell me about yourself?
Yeah, I'm a cloud and DevOps engineer. Currently, I'm working on automation task where I automate the cloud services using Terraform mostly, and then I configure all the things using Ansible. So, for example, I work on a setup where I use Terraform. In that, all modules are getting written which will create a three-tier architecture. Like, it will create VSIs. First it will create VPC subnet, and then inside subnet it will create VSIs, security group, ACLs. And you might have heard about three-tier architecture, in which you will get front end where users will hit their query, and then it will take a query from middle layer where all computation servers will be there, and in backend data a base will be there. And extra services from the cloud used are load balancer, auto scaling. So these are the features I'm using from cloud. Apart from that, I'm using cost bucket from IBM cloud also. um, this is and this all code is written in the Terraform, and that software is getting configured using Ansible. And this all thing get deployed in the Kubernetes, where I take care of pods, the health of pods. I deploy it frequently when development changes happen. We roll it out older version and we renew it with the newer version. Coming to Jenkins, I have also worked on the Jenkins, where I take care of a pipeline, where we have defined all the stages. And once the code get checked in, it checks, deploys, and create the images, Docker images, and later it get deployed in the Kubernetes. So this is what work I'm working right now.
Well, that's good to know. So, can we go ahead with the interview?
Yeah.
Okay, so coming to the first question. How do you design a highly scalable architecture on a cloud platform?
So as I told you, like, basically I have worked on this three-tier architecture, where already auto scaling and a load balancer is there. So that will handle the load, and behind that we have first we have application load balancer. Behind that we have all the servers that act as a front end. So whenever the high load comes, the application load balancer takes care along with auto scaling. So if server get less and CPU and all, then servers will come up based on the request. And then we have computation layer where several servers are there, which will respond you back when it get hit from the front end. And those all are in multiple zones. So let's say if one zone gets down, your service will still run, and it will not show you downtime. Similar setup we have in different zones to handle this three-tier architecture.
Well, that's good. As you have said, you have worked on Terraform. Let's go on to the
Yeah.
next question.
Okay.
What are Terraform state locking and remote state?
So Terraform state is it's a detail of when you trigger Terraform apply, then it creates a required infrastructure in cloud, and it keeps a detail of all that resources that we call it as state file. And that state file is very much important because it keeps the record of services got created in UI, and that we can save it in like S3 bucket or DynamoDB, because it should be safer, because once you lost that, you will lost the detail of the services and you cannot remodify later. Because when you reapply, then it will check what all the services are there, and based on the next modification it will create or delete only that much resources, taking the decision based on the state file. So that is very much important file. And coming to state locking is something where let's say if I have click Terraform apply, so already some modification is going on. And if you'll try to, if somebody else, like we know that on the same code or same infra several developer works. So let's say already modification is going on and some other developer will try to hit Terraform apply. In that case it will show him like the state is locked, because I'm already doing that. And that is very much safe, because it will help that conflict will not happen, and resource will not get deleted or modified by the two developers at the same time. So that's also a very important feature of Terraform.
Okay, so how do you design a reusable Terraform module?
Okay, so Terraform modules means module itself is like we use it to make reusable, because it has a directory structure where we have different files like main.tf, variables.tf, output.tf. So what main.tf will do is it will keep all the main code, and that will be in the variable dynamic format. Nothing will be hard coded there. For example, a VSI, small example, where we keep the details of like only that VSI all in variable format, and that variables, the actual variable we will define in the variable.tf and the required output in the output file. So you don't have to modify the main file. You just come to variable.tf. You let's say this time if you want to create Ubuntu, then change the base name, how many servers you need. So all details you can put it in variable, and you can run the Terraform apply. So this time it will create Ubuntu server for you. Next time if you want to create the Red Hat, then you can just put base image as a Red Hat image and other details for the servers, and next time it will create a Red Hat server for you. So in this way we can create module, and we can reuse it for creating different VSIs, but you don't have to modify the main code or write multiple times the same code.
Okay, so how do you handle sensitive data in Ansible?
So we are handling it using Ansible Vault, and we provide it directly at the runtime. We do not save any sensitive data in the code. We are just providing those, like you can write Ansible command, and later you can invest directly. You can provide that secret name, and it will fetch directly from the HashiCorp Vault or AWS Secret Manager. If you want, you can plug in that also.
How do you optimize Docker images for production?
Okay, so Docker image, like we can optimize Docker image by doing it in a multiple stage. Okay, basically you need to take care, like you should use the smaller base image, and also you can use docker ignore, where the files which is not needed we can keep in that folder, and that will not get uploaded in the Docker image. Also you can keep layer, and only required thing you can take in the images. Okay, avoid running the container as a root. Use a separate user, because root will give entire permission. So based on the user you can give the permission in the image. And also you can check the health check of that Docker image. So these are the steps which we can use to keep the Docker image optimized.
So you must have worked on deployments, right?
Right.
Okay, so what deployment strategies does Kubernetes support, and how do you use them?
Okay, so basically like there are few deployment strategies. One is like rolling update, and one is recreate, one is blue green, and canary. Fourth one is canary. So rolling update is like is the default one, and it gives zero downtime. And because it gives zero downtime, because it's gradually rolled out the things. Okay, and then one blue green is there, where you can do for parallel environment, and it will be very fast. Okay, let me tell it like this. Like rolling update is something which gradually replace the old pod with the new pod. It basically it ensures a zero downtime. The controller using like max surge and max unavailable, and like it helps in the smooth deployment. Whereas the recreate deployment now, like what it will do, it will make entire pod down, and then it creates the new pod. okay, but it causes a downtime. And and as it makes the older pod down, two versions cannot run together. Now coming to like blue green deployment. The blue green deployment, like consider it like blue is the current version which is already running, and green will be the newer version. And once the traffic switches, like once those all green new version comes up and tested properly, all the traffic will be redirected to that one. Okay, so this also helps in like zero downtime, and and it makes highly available application. Now coming to canary deployment. In canary deployment, this newer version will be released on the small percentage of pod with a small percentage of user. They will check it properly. Once that is working fine, then entire traffic will be diverted to the entire pod. Okay.
Okay, so what is idempotency in Ansible?
Okay, so idempotency is like, let's say I have 10 servers and I ran some of the scripts on that one. So in first script it ran something, okay, and when you rerun that same script on those 10 servers, it will not just go and it will configure the entire step or entire script again on those 10 servers. What it will do, first it will or for each task it is having capability to check whether the thing is like, let's say you created one file in the first stage. So next time when you are running the same script on those 10 servers, it will check whether that file is there or not. If that file is not there, in that case only it is going to recreate that file, or else it will not create it. So that capability is called idempotent in Ansible.
Okay, so how do you troubleshoot a pod in crash loop backoff?
Okay, like troubleshooting a pod is like, how we check it is like, first what we do, we describe the pod and we see. Okay, in description also you get a lot of things like with what reason is it is getting failed, or else you can run like kubectl log and then pod, then that will give you the log of that pod, and you can check like in the logs what is the actual error. From there you can start tracking where it is going wrong. Okay, and either or else you can check the readiness or liveness probe. Okay, these are the like now few errors which we usually see is like it might be the image issue or entry point, or it might, if it is showing OOM issue, means there is less CPU or memory in the for that pod, that's why it is not coming up. Okay, or maybe it might be the secret issue in the config map. It is not able to use the exact secret which is needed for that pod, and it might be the RBAC issue which is related to accessing some API or some access that pod should have. So these are some issues we usually see in the pod.
Okay, how do you use Python in your DevOps workflows?
Okay, so I have one image creation step for Python. So we have one repository where we use entire repositories written in Python itself. So what we do, so I have to create one image in the using the packer in for one of the cluster, and how it works is like, we have one entry point main.py where we have defined all the variables what should be passed, like base image, what version, packages, where it is kept like in which bucket, cloud bucket. So from there it will pick that RPMs and it will install and on that base image, and it will create the image. So those all variables are defined in the main entry point, and we have folder wise solution wise folders where, like, if for example if you are creating an image for auto scaling which gets used in the IBM storage scale, so that will pick the that will go and trigger that folder where all the things are written in the Python itself, where it is defined like what all the packages will be installed, or like Python, IBM Cloud CLI, or it will be paths are defined for those packages, and later it will create one VSI and it will install all those packages on that one, and later after that it will create image, and once image is available, at last that script will get end, and these all things will get are written in the Python, and those are defined in the Jenkins. In Jenkins we have a small script that is written in shell script that will trigger that repository, and later that image is get created, and that you can check in the Jenkins log.
Okay, can you describe end-to-end CI/CD pipeline?
So yeah, CI/CD pipeline is similar to what I told. Similar to that only we have other product, and those all are defined. So basically our repositories are tagged with Jenkins using the webhook. So as soon as you push your code, one pipeline gets triggered, and all the steps are written in the Groovy language, where you need first will be checking will be done, later compiling will be done, and once image will be created for Docker, it will get pushed to the Docker hub, and from there it will pick and it will go to Kubernetes, and there the product will be deployed. So this is like our basic pipeline.
Okay, I'm done from my side. Do you have any questions for me?
No, basically no. So thank you so much.
Thank you, Arun.